when you start to write software, you're building an organized system of assumptions. You're assuming that there's going to be some data, some information, and you're going to be able to use, edit, manipulate, and employ that data. So you come up with a theory of what problem you're trying to solve. So you have to really write out a clear problem statement here. That theory will drive your framework, and that framework will require you to describe facts about the theory you've created. So really, in short, I've described the scientific method, but we're going to just dive into this. Some of the considerations that will be in this video follow data science, and they also follow some of the components that you see in software engineering, site reliability engineering, and understanding how your data is working with the system. So I want to describe what's happening. And remember, we need to come up with some considerations about how you will describe your information. And I'm getting to those notes. The first thing we have to do is we have to be able to name what's going on in here. So we're coming here, we're going to name, and that name will let us define properties. And as we start to describe it, we can put things in order from 1 to 10. And we could say 2 is bigger than 1 by the count of one item, and that the difference between 10 and 20 is 10. 10 units would fill that spot. So once we have descriptions, all of a sudden we start to be able to put things in order. We can rank them. We could say this one is the most prevalent, this one is the highest quality, this one is the best performing, this one is this component. And then that sort of lets us predict. Now, with predictions, they are only so accurate and will always have some errors. So sometimes they go wrong. For example, let's say you live in a place with monsoons and it's not monsoon season. And you said the likelihood, I'll predict that it won't rain all of the season until the monsoons comes. Well, you're probably going to be right. And perhaps in certain conditions, there would be an outlier, and there might be one time that it rains. But predictions are over averages over time. Tick-tock. And that lets us explain causes. And then we can manipulate factors, which help us produce or eliminate, and then identify the best explanation for the prediction we made. And you eliminate alternatives by imposing control. Hope you found this useful. We'll see you again.